Hi everybody, welcome again to Pre-Calc 12. Here we are. We're moving a little bit away from algebra. Not really, we still have algebra to do and the Castrol and all that, but I want to talk a little bit about something called Radian Measure. And you're going to need your calculators for sure. So why don't you take a moment to pause the video and go get your calculator, make sure it's ready because we have to do some details with your calculator. In the meantime, we're going to be talking about what actually is a radian. You have to remember the formula for circumference of a circle, right? C circumference is equal to pi times diameter, or 2 times pi times r. We're talking about something called the unit circle, and that's a circle with a radius 1. So if you plug in a 1 for the radius, you get 2 times 1, and the circumference, or the circumference of the circle is 2 pi, and that's a pretty big deal. We'll talk about those things. We'll learn how to convert between degrees and radians, because radians are just really alternative forms of angles. We have, you've been using degrees forever, protractors. Well, those protractors could be recalibrated into radians, and we'll have a look at how to manage that. And then we'll also talk about solving some trig problems using radians and how your calculator needs to work, and especially coterminal angles. There's a fancy little detail about that. So let me go get my calculator, and yeah, we'll have a look. Okay, everybody, so I think that you can see in the top of the calculator there's this DEG button, and that means that my calculator is calibrated for degree mode. And I can change that by hitting the what is it? Yeah, there's a way for me to set it up into radian mode. Let's see if we can if you can move yours out of DEG and into RAD mode. So for this calculator, there's the setup button over here by my thumb, and that will help me get into the DRG, or degree, radian, and gradient mode. So if I hit that, where is it here? Setup. I've got DRG, which is 0, and that means I want to be able to cycle between degrees, radians, and gradients. So for me, I just hit 0, and then I got degrees, radians, and gradients. So I want to be able to cycle, 1, 2, or 3. So if I want to go to radians, I hit a 1, and notice up at the top there, it's in rad mode. And then the other one would be in grad mode. And gradients, we're not going to study about gradients. They're mostly, it's like metric degrees. Instead of 90 degrees being a right angle, 100 gradients is a right angle. And so it's kind of metricized degree stuff. But we're not going to talk about that. We're going to talk primarily about radians. And you need to be able to switch back and forth on your computer calculator. So if you don't know, maybe have a look at the, Google the make of your model and of your calculator and see if you can figure out how to convert back and forth, at least in that upper little screen there for you. Okay, so let's first talk a little bit about what a radian actually is. And it goes back to the idea of the unit circle. Unit circle having a radius equal to 1. So, a radius equal to 1, we start off at 1 over here, and then we work our way around. And at each, 90 degrees, we're at, the point, this will be the point 1, 0, 0, 1, negative 1, 0, and 0, negative 1, right? If we attach it to the quadrant system. So we can calculate the circumference of that, right? The formula for circumference is 2 times pi times r. We know that the radius is 1, and so I plug that in. I get 2 pi for the radius. And I can calculate out that value. It's like, what is it, 6.28 or something like that. But we don't need to actually calculate out those values. When you're expressing a radian, you usually just leave a pi in your answer, and that's a little indicator to let your reader or your audience know that you're dealing in radian measures. So 360 degrees around, all the way around the circle, is the same as, or has a circumference of 2 pi, which is the radian equivalent to 360 degrees. So that's one thing that we can know, right? 2 pi is equal to 360 degrees. Right? 2 pi is 360 degrees. Now that's fine, right? And a lot of people use that as their base equivalency, but there's one that's even easier to use. If I divide both of these by 2, right, if I divide both of these by 2, these cancel out, and I'm left with pi is equal to 180 degrees. And that kind of makes sense, right? It's 2 pi all the way around, so halfway around, or 180 degrees, is just pi. And this is the main ratio that we are going to use in our calculations converting to and from polar coordinates. So let's have a look at how we convert to and from polar coordinates. Okay, so if I want to convert 120 degrees, say, into radians, well, this is one of your skills that you need to know how to be able to do for the unit, and it's pretty simple. It's all ratio work, and then there are some nice little efficiencies and quick tricks that you can use to make this a little bit easier. But given any angle, any degree, you can calculate its radian measure like this. So let's start off. We have to set up a ratio equation because we're dealing with ratios. So that's step 1. So we've done ratio work before in class, and you know, I always go on about ratio equation. I told you the crazy story about, you know, what happened in my household when I asked my wife to do a ratio equation. So we've done ratio work before. When you set up a ratio equation, well, you have to make sure that your letters are the same. So radians to degrees is equal to radians to degrees. And then you start filling in what you know and where your variable is. So we know that pi radians is the same as 180 degrees. So I can fill that into the first part. Pi radians to 180 degrees. Okay, that's that part. And then the second part is, well, I don't know what the radians is. I'm asked to find that. That's my x value. And I know that I've been told to find it for 120 degrees. So there's my ratio equation, and from there I convert to fractions and solve. Now, the solving part is a little bit tricky, and I'll talk a little bit about that in a moment. Right, so I've converted it from its ratios to its fractions, and now I have x divided by 120 over there, so I have to times both sides by 120. And when you do that, I don't want you to give me the decimal answer. I want you to give me the simplified fraction, leaving pi as an expression. So yeah, you're going to leave pi as a variable in your answer, not a variable, but as an expression in your answer, and you're going to get this complicated looking fraction. So let's have a look at that. Okay, so you can see I times both sides by 120, cancels out on the bottom of the x there, and I'm left with 120 times pi divided by 180. And you could calculate that out and you get a decimal answer, and that's fine, but I don't want you to do that. What I want you to do is I want you to simplify this fraction. Right, divide by 10, which will get rid of the zeros, and then what, divide by 6, which will get rid of the 12 and the 18, and simplify it down, and you'll have pi left in your answer. So let's see what that looks like. Right, so I divided off the 10s, right, so I got rid of the zeros, and then 12 and 18 can both be divided by 6, so I divided by 6. So 12 divided by 6 is 2, and 18 divided by 6 is 3. So I'm left with 2 from the 12, right? So 2 pi, don't forget the pi is there. And then 18 divided by 6 gets you 3. So 2 pi over 3. And that's your radian, equivalent to 120 degrees. And that kind of makes sense, right? 2 pi over 3. 2 pi over 3. Pi, so like 3 pi over 3 would be 180. This is not quite there, right? It's 120, it's short of 180, so it should be a fraction less than 1. And 2/3, right? 2 over 3 is less than 1 whole, so that kind of makes sense, and that's how you manage that. So given any angle in degree mode, you can calculate its radian equivalent. And the only time you need to let people know that you're working in radians is if you decide to calculate this out as a decimal. So whatever that decimal turned out to be, you have to put like a little r on top. And we'll look at that when we do the algebra, right? Because that can be a little bit challenging. So let's have a look at converting the other way. Okay, so same job converting backwards, right? If I give you 7 pi over 4 and I ask you to convert it to degrees, I got to set up a ratio equation. And remember, when you're doing a ratio equation, it doesn't matter the letter of the D and the R. Like I could put R first or D first, as long as what you have here on the you know, the left side is the same as what you have over here on the right side. The order is the same. The order can be like they can be backwards as long as it's the same backwards. Otherwise, your ratio is gonna, like, you know, have a little bit of trouble. Right. So we plug in what we know. Pi is equal to 180, and then, you know, you just fill in the other parts. It's gonna, well, let's see what it looks like. Okay, so I have 180 equals pi, and then I have x, what I'm looking for, the degree, for a radian of 7 pi over 4. And I'm putting 7 pi over 4 in brackets just to make it easy to see how things manage inside your, you know, your ratio equation. So I've set up the fraction to look like this, and so x is on top, that's nice, and then I have to multiply off the bottom. So that looks a little bit strange, and let's see what that looks like. All right, so here's how I write it. Okay, I write it as 7 pi over 4 over 1, just to see how these two brackets cancel out. I don't need to write it over 1. I mean, I don't go around saying I got $5 over $1 in my wallet, right? So I don't need to write. We don't usually do that, but here it helps to see how things kind of cancel out. On the other side, I don't write it over 1 because I don't need to. And then I can see what cancels out and how this whole expression plays itself out. Something cancels. Right, it's the pi that cancels on the other side, and that's a nice bonus, right, when the pi cancels. Because now I just go 7 times 180 divided by 4 and pop that off my calculator. Easy peasy. Right, so that's 315 degrees. Now, there's some shenanigans you can do here to make your life a lot easier. I mean, this whole setup of, you know, ratio work is fine, and if you're ever stuck, you can always revert back to, you know, basic principles and do it this way. But I want you to notice something. Check this out. Okay, check this out. This is awesome. What was my original? Right, my original was 7 pi over 4. Right over here. 7 times pi divided by 4. And what did I wind up calculating? 7 times 180 divided by 4. What's the difference between this expression down here and this expression up there? Well, I know you're not blind, right? The only difference is that's a pi and that's a 180. Why is that a big deal? Well, instead of going through all this hassle, we know that pi is equal to 180. Right? We have that over here. So every time you see a pi, sub in a 180. So 7 pi divided by 4, 7 times 180 divided by 4. And that works all the time. Right? Let's have a look at a couple other quick examples. Right, so here's 6 quick ones. Right? Pi over 2. Well, instead of going through all that hassle, which you can do, what's 180 divided by 2? 90. Half of 180 is 90. Okay. Pi over 3, what's 180 divided by 3, or 18 divided by 3 is 6, and that is 0, so that's 60. Pi divided by 4, well, 180 divided by 4, well, that's also pi divided by 2 divided by 2, right? Because divide twice gets you the 4, so what's half of 90? It's 45. You can check it on your calculator, right? Pi 180 divided by 4 is 45. Okay, pi divided by 6. Well, 180 divided by 6 is 30. Pi divided by 12. Can't quite remember my times tables. I think it's 15. 180 divided by 12. Yep, that's 15. And of course, pi divided by 15 will be 12. So these are some of your common radians that you wind up seeing, you know, quite frequently. If you take, you know, university, college level math, most of the time when you're dealing with degrees, usually your profs will like to use radians. I don't know why. I remember my undergraduate when I did my math minor, and like my profs were always using radians. I got to the point where I just knew them off by heart, and so you'll see these. Now you can also extend this idea if you know these ones, to some more complicated ones. So let's have a look at a couple of complicated ones and see how you can kind of cheat it a little bit and be fast. Okay, so let's look at this guy down here, 4 pi over 3, right? Well, I can say that this is 4 times pi over 3, right? It's 4 over 1, and do the fractions, okay? So 4 times pi over 3. Well, we know what pi over 3 is. We just did it. Pi over 3 is 60. So this is like saying 4 times 60. What's 4 times 60? Well, it's 4 times 6. 24 with a 0. So that's 240 degrees. And you can check it just by doing 4 times 180 divided by 3, right? Go the old-fashioned way. Right, check it out. 4 times pi over 3 is 60, so 4 times 60 is 240. Let's look at the one at the bottom, 7 pi over 12. You can do it the same way. We already know what pi over 12 is. Boom. Pi over 12 is 15. So this is really 7 times pi over 12, 7 times 15. Let's see the algebra again, or let's see the calculation. Hey, bada bing, bada boom, right? 7 times 15 is 105. So there you go, right? That's a nice, quick, efficient way to do this. If I was giving you a test, this is probably something you want to put on your formula sheet, but as of right now, I'm not doing any tests until, I mean, maybe we come back, I don't know, and if we do, then I'll have to sort that out then. But for right now, the most I'll be able to get out of you would be like a quiz that I can do on Edmodo. So I haven't even figured that out yet. Nobody's figured it out yet. So this is an idea to keep in mind, right? That being able to do it quickly saves a lot of time, right? Instead of going through all that hassle of doing the ratio work, boom, in and out, nice and quick. Okay, so let's have a little look at doing some algebra with radians. So you're going to need to get your calculators, and you're going to need to make sure that your calculator is in radian mode. All right, let's have a look at a real basic one. If by the time you get here, you know, you've gone through algebra trig 1 and algebra trig 2, and this is like super easy. So let's solve it by degrees here. Let's just review those details, Castrol, etc. And let's do the same thing for radians, okay? So in the degrees, right, you go inverse sine. So I wind up getting a theta reference equaling 30 degrees, right? It's inverse sine to both sides, inverse sine to both sides. And then you go to the Castrol. So what's that? C-A-S-T. Sine is positive, so I have my arms in there and there. So I have theta 1 is equal to 30, and theta 2 is equal to, well, I'm short, right? 180 minus 30. 180 minus 30, which is equal to, what, 150. And those are my two solutions, right? Pretty standard solutions. You guys, I mean, I've seen your homework. Most of it's like awesome. So that's your standard solution in degree mode. In radians, it works the same way, but there's a couple small adjustments you have to make because you're working in radian mode. So you do the same thing. You go inverse sine, right, of sine theta is equal to the inverse sine of 0.5, right? And you're using your inverse sines to cancel them out, right? Those guys cancel. Sorry, this doesn't cancel. Inverse sine of 0.5. You're left with theta reference. And let's see what we get as a decimal off of our calculator. Okay, so I just made sure that my calculator was in radian mode, and I did inverse sine, and I got 0.524. That's a radian, right? That's what 30 degrees would be as a decimal for radian. And you can check that out, you know, by scrolling back and calculating what pi 30 degrees of pi over 6. So pi divided by 6 would get you something like that. So that's my reference angle. Now we go to the Castrol. And here's where things have to be a little bit cautious. The Castrol still applies, right? Sine is positive, so I have my arms over here and over here, and this is 0, but this is not 180, right? 180 is a degree. What's the radian for 180? It's our basic one, right? Pi is 180. Right, so when I'm figuring out my second principal angle, like my first one is just, you know, from 0, right? So that's 0.524, but I'm short, right? So remember, we're measuring that angle, And I'm not quite at 180, or I'm not quite at pi when we're dealing with radians. So I have to go pi minus 0.524. And then I got to calculate that out. And just use like 3.141 for pi, or whatever you want. I'm not going to care about sig figs. So this should be, let me calculate it. Okay, so I calculate that out to be 2.617 radians. Okay, now what am I missing? Remember I was harping on about it, you know, always make sure you include your coterminal statement. Oh yeah, Mr. Gerard, okay, plus 360n NEI, thank you very much. No, it's not 360. 360 is a degree. What's the radian for 360? Goes way back to the very beginning. A full circle has a circumference of 2 pi. So when I write my coterminal statement, I have to include 2 pi. Here's what it looks like, right? Plus 2 pi n. 360 would be 2 pi, right? So we would say plus 360 n NEI, but 360 is 2 pi, so plus 2 pi times n, where n is an element of the integers. So every whole number multiple of 2 pi, or 360, is included. So, you know, I'm still going to care about your radians. And on last year's unit test, I asked you to solve a similar question, a little bit harder, but a similar question using radians. Okay, so you just have to remember a couple, it's the same job, just a couple small adjustments have to be made because you're working in radian mode instead of degree mode. Okay, so I want to have a look at the booklet and see if I can get you going on some of those questions. Page 1 is a little bit tricky if you don't quite remember the first principles of how radian measurement works. So let's have a look there. Page 1. All right, everybody, page 1 of this bad boy. Now, again, we have a QR code that takes you to, I think it's Khan Academy or something like that, that gives you, extra advice on how to manage these details. And up here is a little diagram of, the radian angles and those sorts of details, right? When you're working in polar coordinates, it's not a bad idea to have a system that also is circular. So that's why they look the way they are. So this page is the title page, page 1, bada bing, bada boom, okay? This goes back to talk about circumference. There's the formula up there, and it says, okay, match the arc length. Now, the arc length is like the part of a circumference of a circle. So let's have a look and see what we're talking about, because there's lots of patterns here, and it's easy to get lost. But if you see the patterns, things will snap. Okay, so let's have a look at some of the patterns. All right, so section 1 says, okay, what about if I have 360 degrees, right? What's the arc length? Well, that's just the full circumference of a circle, right? Here's your circle. I'm going 360 degrees around. I know that the radius is equal to 1, so I just plug it in for the circumference. C is equal to 2 times pi times 1. And this little part over here says, okay, well, this helps you figure out the fraction, or I guess the percentage of the arc length. So for 360, it's the full thing. You get 2 pi. 2 pi is what? That's letter C. There you go. Let's have a look at number 2, right? Maybe not number 2, we'll say number 5. Okay, so I've got, what is number 5? 45 degrees. So I know that the R is equal to 1, right? And I know that I got 45 degrees goes in here at the end spot. So I plug that in, I get 2 times pi times 45 over 360. So I calculate that out. What's that? 1/8. Yeah, so this is 1/8. So 2 times pi divided by 8 gets me pi over 4. Right, pi over 4 is letter E. Okay, so that's section 1. Section 2 says, okay, all fancy pansies. So section 2 says, okay, now we're going to do the exact same thing, but now we're going to let the radius equal 2. So everything is the same. The questions are the same, except that instead of being a 1, this is a 2. So all that means is that all my answers from the first section are going to double. So I don't need to work too hard, right? Section number 1, question 1 says, okay, well, I got 360, right? My 360 was, what was that, 2 pi, right? So now it's twice times 2 pi, which is 4 pi. Right? And I don't have to recalculate the wheel, right? I just double all my answers from the first section. The radius is doubled, so the arc length winds up being doubled. Okay, so 4 pi. Which one is that? That's letter B. Okay, so for question number 5, right, same thing. This was my original answer for 45 degrees. Now I just double that. So 2 times pi over 4. What's that, pi over 2? Right, the 2, this is just going to be pi over 2. So pi over 2, sorry, pi over 2. And pi over 2 is what, letter F? Oh. So all you wind up doing is just use your answers from the first section and then multiply them by whatever the radius is. As the radius of your circle gets bigger, your arc length will get bigger, relative, in proportion to that. So, and then at the bottom I say, okay, now do some converting, right? I give you the second to last section, convert 360, convert, 180, convert, what is it, 60 degrees, all of them. We did most of those in the early part of the lesson, and I give you some of them to do down at the bottom. So let's have a look at page 2. All right, so page 2 at the top, I ask you to convert from radians to degrees, and you can just use pi is equal to 180, nice quick, in and out, there you go. Then I give you a couple to do by longhand. And then down the bottom, these last 2 sections down the bottom, well, the first one is just solve by using degrees, like you've done, countless times before. And then I want you to solve them by radians. But if you notice, they're the same questions. I linked them up again. So you can just take your answers over here and convert them into radians, right? So, 2 sine theta is equal to 1, so that's 1/2. So we'll do what, 30 and 150 right here, letter E. And then you just look for the radian equivalence of 30. So 30 is pi over 6, and 150 is 5 pi over 6. You can find those quickly. There you go, letter F. So they're just linked up, right? Solve them by degrees, and then solve them by radians. Use the force, Luke. There's patterns here, and execute those patterns as you can. All right, the last 2 pages are just basically solving using radians. So just their standard calculation questions. You're going to have some square roots in there, and that's fine. Just calculate those out as decimals. So like I got 1 over root 2, convert 1 over root 2 into a decimal, and then go ahead and solve it. Right, down over here you got negative 1 over root 3. Convert that into a decimal and solve it that way. Right, I've written them up because I want to foreshadow for next booklet. And next booklet deals with something we call special triangles, where you see these square roots and stuff in some of your answers, and that's a little bit of foreshadowing. But for now, you can just convert them to decimals, pop them off like you've always been doing. Okay, so that's page 1, or sorry, that's page 3. Page 4 is the same idea, right? By this time, you're probably getting pretty good at it. And then, of course, we have the key to help guide your learning in case you run into problems. All right, so ladies and gentlemen, that concludes this booklet. I'm glad I was able to get it all done in one shot, although uploading this to YouTube is going to take a while, but that's just how it is. So good hunting for you guys as you go through this, and it would be right about now. We'd have one more booklet, and I would typically do a quiz after the booklet after this. But COVID is it's a cruel mistress, and is not helping us manage our assessments properly. So our assessment work is just kind of, well, we do what we can as we can. I'm going to check into the quiz mode in Edmodo, but personally, I don't know. We'll see how it goes. All right, guys, take care. Always good to see you guys. Hey, yeah, you know it. Okay? Ciao.